Hi all, welcome to Statistics and Experimental Design, a subject which it's fair to say is sort of viewed as the Brussels sprouts of a science degree, something that people don't particularly look forward to doing as part of any course, but a form of necessary evil if you like. Well, hopefully within a few short topics, I'll be able to dispel that view of this subject and this field as a whole. And you'll see by learning the theory and applying it to settings which should be familiar to us, we'll see how valuable it is, both in a research setting, but also in a business and industry setting. In fact, all good business should be carried out with proper statistics in mind. We'll be going through 10 topics from the design of experiments which are used to derive data. And when I say experiments, I'm not just talking about an academic setting in a laboratory. I'm talking about in a vineyard, in a stable, in a fish farm or in a field where we're testing a hypothesis that we might have. All of these things require statistics. So after we look at experimental design, so how do we derive valid data? We then look at how do we summarize this data into a nice, easily digestible form, and then finally, how do we analyze this data to see how valid our data is, and also how we can compare two data sets to see if they're different or very similar. In this first set of slides, I'll be introducing you to the topic. We'll go through what the assessments are, who I am, and roughly what is expected of you throughout this semester. Okay, well, here I am cutting a ridiculous pose with my bowling trophy from a ludicrously low-level cricketing competition. My name's Alistair, as I said before, and here is my email address. If you're a purely online student, feel free to contact me at any time. As we'll see in the subject outline discussed a little bit later and found on the Moodle site, we do have regular online tutorials that you can log into, about a little bit better than every fortnight. We'll go through each topic in turn and go through a series of questions as well. Those who are on campus will be having our weekly lectures and tutorials in Building L, I believe. As part of this subject, you are required, well, there is a prescribed text, which is the practice of statistics in the life sciences by Baldy and Moore. The second edition is out at the moment. It's a very good book, one which, well, it is prescribed, so you are supposed to get it. However, there are a number of copies in the NMIT library, and it is also a text that can be found in a number of libraries around the place. If you're an online student, you can get it via interlibrary loan to your nearest community library or university library. But all the question sets which you're required to do from this textbook, I'll be making available to you on Moodle as well. So sort of maybe view the textbook as extra information or another way of explaining certain concepts which may be better or worse than the way I do it, probably better. So that's the textbook. As I said, it's always a good idea to have a good statistical reference in your collection, but if you don't get it, you should be pretty well fine. We also use two computer programs. The first is Microsoft Excel, which most people have for doing spreadsheets, of course. I can't believe I even described what it is. And it is something we'll be making a lot of use of. A lot of people have OpenOffice. That's fine. However, OpenOffice doesn't quite have the same statistical power that Microsoft Excel has. So if you can find a copy of Microsoft Excel on a friend's computer or a library computer, if you don't have it yourself, that would be very, very good indeed. We'll also be using Minitab, which is a dedicated statistical program. People often use a program called SPSS as well, but I just stick to Minitab because it's a little more common. Another benefit of Minitab as well is that it's available to rent throughout the semester, but I'll get onto that a little bit later on. So the million-dollar question is, what do I need to do to pass? Well, obviously I need to get over 50% for the subject, but to do that there's 3 separate types of assessments, and the first 2 in particular you should do very well at if you do the work. And I know every lecturer says that, and it's such a cliche, but I think it certainly is the case for this subject. It says here there's 3 homework assignments. There's actually 4. So I've lied to you in the 3rd slide of the first slideshow. There are 4 homework assignments. 2 of them are essentially take-home tests that you have a week to do. And they're a series of statistical problems for you to complete. You can do them in groups. If you do them in groups, you just have to name who was in that study group who did it with you. That's just to protect those who actually get copied rather than do it as a team. So there's 2 take-home tests. There's 2 mini reports that we do based on a mini experiment which is conducted with another subject. And this is based around the professional presentation of statistics, and is a very useful thing to practice because consultants get paid a lot of money for doing a very similar thing. So these 4 homework assignments, the 2 take-home tests and the 2 mini reports, are worth 25%. They're spread out throughout the semester. All the due dates are available on Moodle, but I have the subject outline open, and I can tell you that the first assignment is due in week 5, the second one in week 8, the third one in week 10, and the final one in week 12. So they're nicely spread out. There's a mid-semester test. It's completed on Moodle. You have a week to do this as well. You have an hour and a half to complete the test. It's worth 25%. Then at the end there is, I should say that the mid-semester test is in week 9 after the mid-semester break. So that's pretty good. And then there's a final examination in the examination period at the end of semester. It's worth 50% and it's 2.5 hours long. And it's quite difficult. But in saying that, it's not really that difficult. You have a full practice exam with work solutions, and statistics is one of those topics where you can only be asked certain questions. There's only so many statistical concepts that we'll be learning, and there's only a certain amount of questions that can be asked within those concepts. So there won't be anything that's going to take you by surprise in the exam. It's just quite long, being 2.5 hours, and can be a bit of a brain drain as well. But by that stage, even if you decided you didn't even want to study, you should be pretty close to 50%, again, if you've done the work. The final examination in this subject is really there to allow those people who want to excel to excel. The classes for this subject are fairly simple. Each week we start off with an hour tutorial where we'll look at a couple of key problems, and then after that there'll be an hour and a half of a lecture where we'll be introducing the new topic or the next topic. These are available live on campus, and the audio will also be made available online in this very format. Those who are online students only, we have tutorials every fortnight, as I said before, on a Tuesday night between 6:30 and 8 o'clock. It's a little bit more than every fortnight. I think there's 7 or 8 throughout the semester. And they'll be structured exactly the same way. We'll start off with a few key problems, and then I'll introduce key topics, or the take-home messages from the key concepts, I should say, in each of the topics. To accompany the tutorials and the lectures, the version of Prax that we have in Stats are computer-based exercises, and these are done in Microsoft Excel and in Minitab. And what I get you to do is read a scenario, receive a data set, and do the analysis. I'm available every afternoon to assist with this, but they can equally be done in your own time. For the online students, between 8 and 8:30, I can answer specific questions on these computer exercises. But again, there's nothing in them to trip you up, so it's more about putting in the time to do them. And I think you'll see that they're all designed so to be activities which will resemble academic activities you'll be doing in other subjects, so you'll be able to see how useful these stats that we're learning are and how you can apply the methods we're using to other subjects as well. Obviously, I wouldn't be a boorish lecturer if I didn't go through, as I already have, to be honest, and so yes, I am being a boorish lecturer by repeating myself. If you do the time, you'll get a good mark in this subject, and you'll live the rest of your life having the power of good stats behind you. And you'll see how valuable you become to your employer or to your company with these abilities. The concepts themselves that we cover in this subject are not difficult. Really, the biggest thing about statistics is deriving an average or a mean and then testing how good that mean is. That's really 90% of statistics. Talking about 90%, nearly 90% of students pass this subject, 89%. But sadly that means 11% also fail the subject, and I can tell you from experience they are the students who don't put the time in. The average mark in this subject is 66%. So not high, but I think it more reflects the amount that people put in again. And I really am repeating myself there. But if you do the homework and attend the tutes, you'll be absolutely fine. In this subject, we kick things off by looking at descriptive statistics. How do we present and summarize data? Before we can do that, of course, we have to derive this data. So we will look at experimental design. In other words, methods for proper sampling. Proper sampling being methods that give us valid data which actually represent the system we're looking at. It's very easy to get data. It's a little bit harder to get data which is actually representative of the experimental system that you are interrogating. Descriptive statistics or summarizing statistics, there's some examples there. A classic descriptive statistic is the average. So the average speed of a car on the Princes Highway is 104 kilometers an hour. That is a descriptive statistic. If I was to say that station wagons drive faster than hatchback cars on the Princes Highway, that would be a form of inferential statistic. We're using descriptive statistics for a comparison. So I give some examples there of inferential statistics, or the objectives of inferential statistics. From a grape example, A descriptive statistic might be, what is the average sugar content of grape berries in a vineyard? That would be a descriptive statistic. An inferential statistic would be a test we use to work out whether or not grapes in vineyard 1 have a higher sugar content than grapes in vineyard 2. So, what do you need? Told you about the prescribed text, and I introduced Minitab in Excel. Well, here is the link to access a rental copy of Minitab. You can purchase Minitab as well quite cheaply as a student, but renting it's always a very good idea. There's trial versions you can get, but renting it's around $30 for the semester. It's $30 US. Get it on your computer. However, your computer has to be a PC. It doesn't work on Apple. This is a tragedy, and yes, I use an Apple at home as well, but it does mean you will need a PC to do some of these analyses, and I do apologise about that. Now, I did say I'd repeat myself a little bit in this presentation, and I would be boorish. I think I've ticked both those boxes in here, just to repeat myself again, but this is a personal guarantee. I guarantee you now that the ability to use and interpret statistics will make you exceptionally more valuable in industry. Employers love people who understand stats and can use stats in the proper way, generally because they can't themselves. So that brings us to the end of my introductory little lecture here, which moves us along to topic 1 proper, which is the start of our investigation of descriptive statistics. Within this next topic, we'll be looking at terminology which is commonly used in statistics and experimental design. For example, the difference between a sample and a population. We'll be looking at what categorical data is and what numerical data is, and how we have to treat them differently. For most of the course, we'll be looking at numerical data or parametric data, not as much on categorical data or non-parametric data, also known as non-parametric data, I should say. And at the end of this topic, we'll be jumping into our first stats. We'll be looking at measures of the center of a data set, so the most typical value as measured by the mean, also known as the average, and the median. And we'll finish off by exploring that number which gives people the jitters for no apparent reason, which is the standard deviation. And I start off with these because once you truly understand what the mean is, and most of you probably already will, and you know what a standard deviation is, then you can interpret most of the results presented in scientific and industry journals. So I'll see you in the next topic.